wanted to do another example of effective rate of interest because I feel like I messed that up in the last discussion. So let's find the effective rate of interest for a credit card that has a 12.9% rate of interest that's compounded continuously. So what I told you to do was to use, of course, your compounded formula and go ahead and use a principal of $100. Now honestly you could use any amount you want, it's just that using $100 makes it really easy to figure out the answer. And then the rate is what you're trying to find, and the time is going to be 1 year. Okay? So we go $100, and notice how $100 wasn't listed anywhere in the problem? I'm just telling you to use $100 every time you do a problem like this. Okay, and then you do e to the 0.129 and then times 1. So put that in a calculator. 100 e to the 0.129 and then times 1 doesn't change anything. So I get $113.77. That means that my original $100 has now turned into $113.77. That means the interest for 1 year is $13.77. And so that means the effective rate of interest is 13.77%. Because if you earn $13 or pay $13 on $100 in 1 year, that's the same as having that is your percentage. Because the word percent means per 100. So if 100 is our principal, we're earning $13.77 per 100%. Okay, let's do another example of something different. What rate do we need? Let's do a different compounding. Compounded annually to double our money. Double our investment in 5 years. Okay, well, our formula is A equals P times 1 plus R over N to the NT power. Did it give us an amount? No. The only hint we have for amount is double. That means you can choose any number you want for P and then double it for A. So the easiest thing to do is to just let P equal $1, and that way A just equals $2, and those are really easy numbers to work with. You could use any numbers you want. You could use 500 and then 1,000, but you're going to end up having the 1 and the 2 be in the equation in the same place anyway. Watch why. Let's go ahead and just do another amount, and then you'll see why just using 1 and 2 is just as effective. Or let's use the example I just did. P is 500, A is 1,000. So was that in the problem anywhere? No, it wasn't. We just made up those numbers so that it fit the description. Okay, so then we would have 1,000 equals 500 times 1 plus R is what we're trying to find. N, compounded annually, means once per year. And so then once per year times 5 years. The first step you have to do to get to R is to divide both sides by that 500. When you divide 500 by 500, you get 1. When you divide 1,000 by 500, you get 2. So you end up with 2 equals 1, which you don't even need to write that 1, times 1 plus R over 1 to the 5th power. Okay, so for that example I used the 500 and the 1,000, so my money was doubled. What if I had used the simpler numbers, $1 and $2, so that the number was doubled? $1 principal, $2 total amount. See how I still ended up with the same numbers. Okay, now to solve for r, we want to get rid of this fifth power. This one, remember, doesn't even need to be there. Okay, so we're going to do the fifth power of both sides. And that was to the fifth, so those just simply cancel. And, you know, r over 1, we don't even need to write that way either, correct? So we now have the fifth root of 2 equals 1 plus r, basically. Because r over 1 is the same thing. So the rate is going to be the fifth root of 2 minus 1. Well, we don't want that type of answer. We want to put it in our calculator. So another way of doing a fifth root is to the 1/5 power. So I'm going to go 2 to the 1/5 power, and then take that answer and subtract 1. That takes it down to a percent. So the rate will equal 14.9%, because this answer was 0.1486, blah, blah, blah. So that rounded to this, and I changed it to a percent instead of the decimal that it originally was. So in case you forgot what I did here, to do this in my calculator, I simply did 2 to the 1/5 power, because that's the same thing as the fifth root of 2.